Hello, welcome to my channel Speak with Math. Look at these problems on the board. First one is find the volume of the solid formed by the revolution about the major axis of an ellipse with the axis 2a and 2b, a greater than b. The second one is find the volume of the solid formed by the revolution about the minor axis of an ellipse with axis 2a and 2b with a greater than b. What is the difference between these two questions? Here, in the first case, revolution about the major axis. Since a greater than b, so the major axis is x-axis. And in the second case, revolution is about minor axis, that means about y-axis. Now, to find the volume of solid of revolution and the revolution about the x-axis, revolution about x-axis. If the area bounded by the curve y is equal to f of x, the x-axis, and any two fixed lines x is equal to a and x is equal to b, be revolved about the x-axis, we get a solid of revolution and its volume v is given by pi into integral a to b y square dx. Now the equation of ellipses, this is the general formula to find the volume of solid of revolution, and the equation of ellipse is x square divided by a square plus y square divided by b square is equal to 1. I am solving the first question. Now this is the equation of ellipse. And we know that ellipse is symmetric about both axes. Symmetric about both axes. Since the equation contains even and only even powers of x and y. So this is symmetric about both axes. Now, since a greater than b, the major axis is x-axis. Hence, this is x-axis and this is y-axis. Here minus a 0, here it plus a 0, here 0 plus b, and here 0 minus b. And the given solid is obtained by the revolution about the x-axis of the area enclosed by the portion of the ellipse in the first and second quadrant and the x-axis, that is this shaded region, area enclosed in the first and second quadrant. Since a greater than b means the major axis is x-axis, so this portion of area is revolving about x-axis, only this portion, area enclosed in the first and second quadrant, is revolving about x-axis. We obtain a volume of solid of revolution. Now, since the ellipse is symmetrical about the axis, so the required volume is twice that of the volume obtained by revolving the part of the ellipse in the first quadrant about the x-axis. That means the ellipse is symmetric about the axis, so the required volume is twice that of the volume obtained by the revolution about x-axis the portion of the curve in the first quadrant only. That is the required volume V is equal to 2 into here limits varying from 0 to a pi y square dx. X varies from 0 to a. This portion is revolving about x-axis, twice that volume gives the complete volume of solid of revolution. Otherwise you just integrate it from minus a to plus a. If you are integrating from 0 to a, 2 into that volume gives the complete volume of solid of revolution. Here the equation of ellipse is x square divided by a square plus y square divided by b square is equal to 1. Then y square is equal to 1 minus x square divided by a square into b square is equal to b square divided by a square into a square minus x square. This is equal to 2 pi integral 0 to a. Y square is b square divided by a square into a square minus x square into dx. That is 2 pi into b square divided by a square integral 0 to a square dx is a square x minus integral x square dx is x cube by 3, limits varying from 0 to a. Integral x raised to n dx is x raised to n plus 1 divided by n plus 1 plus a constant c. So here a square dx is integral a square into dx is a square into x minus integral x square dx is x cube divided by 3. Limits varying from 0 to a. That is 2 pi b square divided by a square into a cube minus a cube by 3 after applying the limits. If we apply the lower limits it becomes 0. So we get 3a cube minus a cube. 2 pi b square divided by a square into 3a cube minus a cube whole divided by 3. That is 2 pi into b square divided by a square into 3a cube minus a cube is 2a cube divided by 3. So we get 4 by 3 pi a b square. This is the required volume of solid of revolution about the major axis. V is equal to 4 by 3 pi a b square. Now consider the second problem. Here revolution about the minor axis, that is y axis. The equation of ellipse is x square divided by a square plus y square divided by b square is equal to 1. Now if the revolution about y axis, this is the equation of ellipse. If the revolution about y axis means the volume of solid generated by the revolution of the area between the curve x is equal to f of y, the y axis, and two abscissas at the point y is equal to c and y is equal to d is given by v is equal to pi into integral c to d x square dy. Now this is the general formula of volume of solid of revolution about y-axis. I'm just x, y, here it is minus a0, 0 minus b, here 0 b, x square divided by a square plus y square divided by b square is equal to 1. Equation of ellipse. Since a greater than b, the minor axis is y-axis. So here revolution about y-axis. And the required volume is obtained by the revolution about the y-axis of the area enclosed by the portion of the ellipse and the y-axis. That is this portion of the curve. The shaded region is revolving about y-axis. Revolution about y-axis. The area enclosed in the first and fourth quadrant is revolving about y-axis. We obtain a volume of solid of revolution. And since the ellipse is symmetrical about the axis, so the required volume is twice that of the volume obtained by revolving part of the ellipse in the first quadrant about y-axis. That is, just consider this portion. The portion in the first quadrant is revolving about y-axis. Then the required volume V is twice 2 into pi, limits varying from 0 to y is equal to 0 to b x square dy. Since the ellipse is symmetrical about the axis, so the required volume is twice that of the volume obtained by revolving part of the ellipse in the first quadrant about y-axis. Revolving about y-axis, 2 into that volume gives the complete volume of solid of revolution. Now x square is what? X square is equal to 1 minus y square by b square into a square. That is a square divided by b square into b square minus y square. So the required volume V is 2 into pi, limits vary from 0 to b y square x square dy. That is a square divided by b square into b square minus y square into dy. That is 2 pi into a square divided by b square integral 0 to b square minus y square into dy is equal to 2 pi a square divided by b square y integrating with y. So here y cube by 3, limits varying from 0 to b, 2 pi a square by b square into b cube minus b cube by 3. So we get the required volume V is equal to 4 by 3 pi a square divided by b square into b cube. That is 4 by 3 pi a square b required volume V is equal to 4 by 3 pi A square B. So we have seen that the volumes obtained by revolving the ellipse about major axis and minor axis are different. The volume of the solid formed by the revolution about the major axis of an ellipse with axis 2A and 2B with A greater than B is 4 by 3 pi AB square. Revolution about major axis. And the volume of solid formed by the revolution about the minor axis of an ellipse with the axis 2A and 2B with A greater than B is 4 by 3 pi A square B about minor axis. And we know that the volume of the sphere is obtained by the revolution of the circle about one of its diameter when A equal to B. In this example, then that ellipse becomes a circle. Ellipse become a circle if A is equal to B. So the volume of the sphere is what? V is equal to 4 by 3 pi. If A is equal to B, this becomes 4 by 3 pi A cube, where A is the radius of circle. I think you got an idea about this part, that is, if the volume of solid formed by the revolution about the major axis and minor axis are different. Here we are using disk method to find the volume of solid of revolution. That is, we obtain a volume of solid of revolution. That is, if this is the volume of, this is the solid of revolution, how we get this integration? Pi into integral A to B y square dx. If it is revolving about x-axis, consider a small disk from this portion. That is a small, I'm just cutting a small portion from this solid. Then the area of this small portion, that is a disc shaped portion. Area of this portion is what? Pi. Area of disc is pi r square. Here radius is y. So pi y square. Now to find the volume of this disc, dV is what? Area into this thickness of this disc. This thickness is what? Dx. So pi y square into dx. Now to get the total volume V, we should integrate it from, if it is A and if it is B, then we should integrate it from A to B dV. That is integral A to B pi into y square dx. Thank you.